sections today, and what we're going to be talking about are different ideas of the behavior of functions. So different special features of the graphs of equations. So the first thing we're going to talk about is end behavior. End behavior tells us what those arrows at the end of our graph are doing. And we're going to do this part without our calculator. So just by looking at the equation, we can tell what the arrows at the end should be doing. So whenever we graph an equation, we always put those arrows to show it goes on forever. So the question with end behavior is, are the arrows pointing up or are the arrows pointing down? There are two rules that allow us to know what those arrows should be doing. The first rule says if the degree means highest power. So if the highest power in the equation is even, then the ends are going to do the same thing. Either both go up or both go down. If the degree or highest power is odd, then they're going to do opposite things. So one's going up and one's going down. We can remember this because the word odd, if we think of synonyms for the word odd, a lot of times we might come up with different. Like if I say, that's odd, what I mean is it's kind of different than what I was expecting it to be. So odd can mean different or opposite. So when that highest power is odd, the ends are going to do the opposite things, one up, one down. Then we're going to look at the leading coefficient. The coefficient is the coefficient of that highest powered term, not necessarily the first coefficient. So we don't necessarily care what the first term says, but that highest powered term, we're going to look at the sign in front of it. If it is positive, then the right-hand side goes up. If it is negative, the right-hand side goes down. We can know what the left-hand side is doing because we've already decided that they're either doing the same thing or opposite things. So in this example, we care about the highest powered term. So that would be the negative x squared plus 1. Okay, we care about the term with the highest exponent. In that, we care about the power. Is the power even or odd? Even. 2 is an even number. What does that mean? They're going to do the same thing. Even powers mean both ends are doing the same thing. So they're either both going to go up or both going to go down. Then we look at the sign in front of that term. The sign in front of that term is negative. That tells us about what the right side does. So the right side is going to go downward. What's the left side going to do? Go down because they're doing the same thing. We have no idea what happens in the middle of this graph. Okay, well this one we really do because it's x squared and we know that x squareds make parabolas. But it could be a whole lot messier of a function and we'd have no idea about the middle. But we know at least at the ends, both arrows are pointing down. Since this is just a parabola, there's nothing weird that happens in the middle. But there could be all kinds of bouncing around happening in the middle. We don't care about that. All we care about is what are those arrows at the ends doing. So for your answers, you could either draw me a sketch, or you could just say what the sides are doing. So let's look at another example. We care about the highest powered term. What is that one here? Okay, so we care about the term with the x cubed. Is the power even or odd? What does that mean? They're going to do different things. Then we care about the sign of that term. Is the sign positive or negative? Negative, because it's negative 10. What does that mean?
Go down.
The right is going down. And the left will be going up because they're doing different things. So in this one, I know that on the left-hand side it's pointing up. On the right-hand side it's pointing down. I don't really know what's happening to connect those arrows. It could do something like this, but I don't know. I don't know how many bumps there are going to be in the middle or even if there are any bumps. But I know that the left-hand arrow is going up and the right-hand arrow is going down.
For our answers for this, does it only have to be in that box?
Yep. Your answer would just be telling me what the right and the left are doing, or you could draw a sketch to show what the right and the left are doing.
Does it matter in the sketch if it's just like a line and then it going up?
It doesn't matter what the middle of the sketch looks like because we don't know what it would really look like. What term do we care about here? The 4x to the 4th. Power? Even means same. Sign,
Right down.
positive, means
Right is up.
right is up, left is up because they're the same. Last one of this type, what term do we care about?
X. The fifth.
X to the fifth. Now in all four of these examples, it happened to be the first term. It's not always the first term. Look for the highest power term. That's the term that we really care about. No matter how long the equation is, it could have like 15 terms. Just look through them, find the one with the highest power, and that's the one that determines everything. So the power on this one is odd, which means different. And the sign is positive, which means
The right is going up. And the left is going down.
the right is up, so the left is down, because they're different. Okay? Questions on this? In the homework for these questions, if you look at the directions, it's going to say something like, if x arrow sideways 8, then f of x arrow blank. And the directions are going to tell you to fill in the blank. This is some different notation that we're not going to cover this year. If you go on to pre-calc or calculus, you'll use this notation and realize it's really not as confusing as it looks. But we're not going to worry about that. So when the directions tell you to do it this way, I don't want your answers that way. I want your arrows with the words right and left and arrows pointing up or down. Okay? So don't worry about what the directions are saying as far as filling in the blanks and using infinities and stuff like that. Okay?
So you want us to have like a power?
No, all I need is what's in the box is enough for your answer. You don't have to show me kind of the work of how you logicked that out.